Yeah. Hello everyone. Good afternoon. My name is Joss, and I'm here with my friend Brandon today to talk about penetration testing and in general, and Metasploit as the pen testing tool. For the presentation outline, first we're going to introduce you to penetration testing. We're going to talk about the type of tests and hackers, the rule of engagement, the frameworks, and the typical test cases of penetration testing. After that, we will move on to Metasploit, which is one of the most used tools in penetration testing. We will talk about how you would use Metasploit, and then we will end the presentation in demo. So for computer security in general, there are three types of hackers, as you all might already know. The first one is white hats. This is a term that we use to describe hackers that have been authorized to conduct a penetration test to a system within the bounds that have been given to them. The second is gray hats, which are basically people with good intention that try to find any vulnerabilities in the system. But the distinction between the gray hats and the white hats is that gray hats will try to find these vulnerabilities without any prior provisions, therefore sometimes illegal. The third one is black hats, which are your typical malicious hackers that illegally break into your system for personal gain. So from the definition of the three types of hackers I just mentioned, we can conclude that penetration testing is an authorized simulated cyber attack on a computer system to identify any weak spots or vulnerabilities that can be taken advantage of by black hats. In penetration testing, there are also three types of testing, depending on how much knowledge you have at the start test. The first one is white box testing, which means that you as a penetration tester have full access to the system information. This includes source code, architecture, documentation, and so forth. The second one is gray box testing, which means that you have the access and knowledge level of the user, potentially with some kind of elevated privilege on the system. The last one is black box testing, which essentially means that you don't have any internal knowledge of the system and you will try to find any vulnerabilities from the outsider perspective. So as I mentioned earlier, when I was talking about how white hats operate within the given bound, I was referring to the rules of engagement of penetration testing, which I will explain more in the next few slides. So rules engagement essentially is a document that is drafted before the white hats can do any penetration testing to the system. The set rules that the white hat needs to follow. This document also acts as the written permission to testers for legal purposes. It basically says that any attack that you will do to the system is already authorized and cannot be used against you as long as you follow the rules of the course. There are 6 parts of the structure of the rules of engagement. The first one is the scope of tasks that you will be doing to the system, the risk and limitation of doing the task to the system, the logistic, when to stop the testing, how to handle data that you will come across, and lastly, how to properly report your results. So the first one, the scope of the task, it will specify what is the target, for example, which servers, application, or network that they have been given permission to attack, what kind of attack to the system that's allowed or not allowed. For example, maybe you're not allowed to do any denial of service attack to the server because it will disrupt their business activities. And then what can you do the penetration testing on what time, on what occasion, and lastly, how much effort can be used when you're attacking the system. The second is the risk and limitation, which specify how far can you attack and damage the system as a result of doing your task. Is it possible that the task occurs without dealing any damage? If not, can it be reversible with the help of the tester? And it's also important to remember that this is the tester duties to do as little harm as possible to the system that we're testing. And then the third one, we talk about the logistic of the test, which essentially just specifies who is involved in testing and what is the schedule plan or the time window for testing. The termination of testing specify which when you should stop your testing. Is it after a certain time frame, after all permitted attack factors have been examined, or is it just after detection of the vulnerabilities? For example, CMS, which stands for Centers for Medicare and services in the US requires that the penetration testing should stop immediately when critical vulnerability has been found or evidence of prior attack has been found in the system. And then data handling, which specify how you should handle all the data that you have come across while you're testing, how it should be disposed of after you're done with testing, or what security measurement that you need to take to keep the data safe. After you're done with testing, you will need to also handle data of your report, like who is allowed to see the result or should it be encrypted. Lastly, the reporting part will specify how you should construct your report after you finish your penetration testing to the system. For example, so tactics were used, when they were used, and then what vulnerabilities that you found in the system, how critical they are, what risks they pose to the client or to the system, which part of the system is affected, and whether the public can exploit these vulnerabilities. After you found the vulnerabilities, you will need to specify what changes that you made to the system, and how should the client address to these vulnerabilities. So here are some examples of risk engagement we found on the internet. For now, we'll check out the Microsoft one. So yeah, so this is the penetration testing rules of engagement. Rules of engagement for Microsoft Cloud. As you can see here, there's a scope for the test. It specifies which Microsoft products are in scope for the test. So, for example, you can see here, it's Microsoft Azure, Microsoft Power Platform, and etc. And it also specifies how to report the security issue that you found while you're testing. There's a specific statement here that said that you're agreed that you will not disclose the vulnerabilities that you found when you're testing to the public until you heard from the Microsoft that the problem is solved. And also tells you how do you get compensated if you found any vulnerabilities in their system, which usually called as a bug bounty awards. And then you can also see here that what type of activities are prohibited during the testing. So as you can see here, is you're not allowed to do any kind of denial of service testing, which is weird for me at first, because it just shows that they are not confident with their education skills to DDoS attack. But then I just realized that this whole document is designed for the general Microsoft user. So of course they won't allow the users to do a DDoS attack the server. And then there's also the activities that they are encouraged, which is not really interesting thing. And then there's one more. And unlike the Microsoft one, this document is drafted for a security company that is hired to do penetration testing on the Qualified Labs. And as you can see, that the way they structured the document is different with the one that we see in the Microsoft one. As you can see here, that there are task scopes, there are project logistics, as I mentioned before. There are assumption and limitation here, and it's a 30 pages document, so I will not go through it by one by one. But it's there if you are interested to see. So now that we understand the rules of engagement, we'll move on to the typical penetration testing phases. So this is generalized workflow on what you will do when you're doing penetration testing. First, you will need to do some reconnaissance to the target system, find as much as information as you can get before trying to get into the system. After that, you will do some scanning with technical tools like Nmap to further your knowledge about the system. then you will need to gain access to the system by sending payloads or exploits to the target system based on all the data that you have gathered in the previous steps. After you gain access, you will need to maintain an access so that you can do whatever objective that you need to do in the system. Maybe like getting as much as data as possible. After you're done with the objective, then you will do some analysis and report all your process and findings to the client and client issue. Moving on, we're going to talk about the pen testing frameworks. First is the NIST, which stands for National Institute of Standard and Technology in the US. It was first published in 2014, and it provides some guidelines on how organizations can protect themselves from cyber threats. This framework is also applicable to both pen tester and security analysts. This cybersecurity framework includes five steps that your organization needs to know. First is identify. How is our organization structured? What system does it rely on? What could make it vulnerable to attack? And the second one is protect. What safeguards are in place to mitigate the attack? The third one, detect. How could we detect anomalies and anticipate attacks? And fourth, respond. How can an organization respond to an ongoing attack? And the fifth is recover. How can an organization recover from attack? The next framework is the open source security testing methodology manual, which is a complete methodology for penetration and security testing, security analysis, and the measurement of operational security towards building the best possible security defense of your organizations. You can check out this link if you're interested. The link is 213 pages of manual. The last one is OWASP. It stands for Open Web Application Security Project. It is an open source project that applies specifically to web facing application, and it is actively and continuously updated. Here are the top 10 vulnerabilities that I guess all of you are already familiar with. So these vulnerabilities can be a good start if you are doing any penetration testing for a web-facing application. So there are a lot of powerful tools that you can use for penetration testing, and among them are these four: Wireshark, Pursuit, Metasploit, and Nessus. But for today, as you can expect, we'll talk about the Metasploit. So for the next couple of slides, we'll try to answer these three questions: what is Metasploit? Why you should use Metasploit if you're doing penetration testing? And lastly, how does Metasploit work in a really simplified way? So Metasploit is a modular penetration testing platform that enables you to write, test, and execute exploit code to the target machine. Metasploit also contains a set of tools that you can use to test security vulnerabilities, enumerate networks, execute attacks, and evade detection. In conclusion, Metasploit is a platform that can provide a complete environment for penetration tester and exploit development. This is why Metasploit is not only popular tools for the pen tester, but it's also a go-to tool for black hat hackers. The Metasploit project includes Metasploit framework, which is the free version, and the one that we're going to use today